Thank you, Clint. Hi, everyone. My name is Dan Banger. I do lead business development at Amazon AI, and I've been at AWS for about 5 years now. My first 3 years at AWS, I was managing engineering teams in big data and then DevOps. So if you called AWS 5 years ago to complain about Hadoop, you were probably talking to my team. I'm here to talk about AI at AWS. And then this talk is more on the platform and engineering side, and then where are the areas where we think at AWS we can innovate on behalf of our customers and what we're doing about that. For the past couple of years, we've been innovating on behalf of our customers, and we're very aggressive at our pace of innovation and the pace at which we communicate with our customers to understand what their challenges are and to factor and build that into technologies that we provide. And by customers, I mean internal and external customers. But to set the stage as to why we're all here and why we care about AI, I think we can all agree that AI can transform customer experiences in the way you deliver products to your customers with chatbots. I've seen a lot of examples out there. It can improve on business operations, the way documents can be processed to innovate on inventory management, workforce management. It can improve on decision making and innovation and ultimately bring competitive intelligence or competitive advantage to your companies and your businesses. And so our mission at AWS and the mission of the team that I work for is to put machine learning in the hands of every developer. We are on the builder side. We are in the back end of most of the products that you see out there. And to achieve that, our strategy is very simple. We listen to our customers aggressively. We're very customer obsessed, and 90% of our roadmap is actually driven by the customer's demand. And besides that, we also know a thing or two about doing AI at scale with a very large customer called Amazon.com. And from that learning, we have a massive pace of innovation that puts us in a position to innovate in terms of breadth and depth on behalf of our customers. We also do embed research and development in the products that we build. And we don't just do research for the sake of research. We do applied research to make sure that that's applicable in specific domains like retail and healthcare, and ultimately help our customers. By achieving that, or by delivering that strategy, what we've observed so far on the cloud is that tens of thousands of developers are actively building machine learning models on the cloud. We're seeing a 250% growth year over year. And 8 out of 10 of TensorFlow workloads, if you're familiar with TensorFlow, are actually running on the AWS cloud, including the benchmarks. Lots of customers are using machine learning on AWS today. You might recognize a lot of these logos. Some of my favorites are like NASA providing the voice commands to the robots using voice transcription technologies on AWS. If you're looking for an apartment and you're using Zillow, you're probably using a machine learning model that was built on AWS in the back end. If you go into the doctors and you're using ZocDoc, then your insurance card is analyzed using a TensorFlow model built on top of AWS. So we're seeing a massive movement of customers from startups to large enterprises adopting machine learning on AWS. And like I said earlier, we work backwards from our customers' demand. So in the past year, we've had more than 200 releases just based on what our customers asked for. If you're familiar with the Amazon machine learning technology stack, it used to look like this all the way up until last week. So we have AI services at the top of the stack. These are pre-baked services that are built already with machine learning and deep learning in the back end. And folks don't have to know any machine learning in order to use them. So we have chatbot technologies, we have computer vision and speech technology, and everything that comes around that. We also had machine learning services in the form of Amazon SageMaker, which is an end-to-end machine learning platform that provides supervised learning, unsupervised learning, Jupyter notebooks, and everything that comes around it. And of course, at the infrastructure and machine learning frameworks layer, AWS is frameworks agnostic. So we do support every framework because we believe that it's too early to dictate what customers have to use today in order to build machine learning models. If you follow the industry, you would realize that there is a net new scientific paper coming out almost every day with the solution built in TensorFlow, PyTorch, MXNet. All of these tools have their own strengths and weaknesses, and we make sure we support all of them. As of a couple of days ago, or as of a few days, we've released more services in the form of Amazon Textract, forecasting, personalization, and some other improvement to the machine learning services stack. And that's what I want to focus on today. I want to focus on what we release, what does that mean, what was our strategy, building these additional products and services, how we think about the market, how we think about the benefits of these to our customers, and hopefully I answer some of the questions that are not in our public documentation, and I'll be available outside to answer more questions. So often our customers are asking, well, how do I get the benefit of the kind of technologies that you're applying at Amazon.com? Things like recommendations or forecasting at a massive scale. So let's start with the forecasting problem. Well, forecasting is a very intricate and complex problem to solve. You could either over-provision or under-provision in this case, in which sense, I mean, in which case you actually disappoint your customers because you haven't provisioned enough capacity in terms of products or whatever to serve them. Or you can over-provision, in which case you eventually waste money. And it gets even more complicated when you have multiple products that are potentially related that you want to do forecasting on. And forecasting is not just a product inventory forecasting problem. It could also be a web traffic forecasting problem, or it could be anything from retail to customer analytics to pretty much everything you have going on. So that's why we created Amazon Forecast. Amazon Forecast brings the forecasting technology that we use at Amazon.com out to the customers. It's a managed machine learning service that is essentially designed to provide accurate forecasts to customers. It's actually a solution. By providing the same type of forecasting algorithms that we use at Amazon.com for our own retail challenges out there for customers to consume. So with Amazon Forecast, customers can have their own custom models built on the side, and with these custom models, they can be trained on their data set in multiple specific domains like retail, like customer analytics, like web traffic analytics, inventory analytics, and everything else you want to forecast, or anything that is custom. And the service will be able to build the infrastructure, select the proprietary Amazon.com algorithms that we use internally, and apply that to your forecasting problems. The next problem was recommendations. Well, we do a lot of recommendations at Amazon, and recommendations are very different depending on the topic and the domain you want to provide recommendations in. If you're in the music domain, then you probably want to use tracks and artists and albums to recommend to your users. In the film, it's different parameters for different products or different contexts. So recommendation is complex. And we know a thing or two about recommendation. That's why we externalize this solution again in the form of Amazon Personalized. Amazon Personalized provides real-time personalized recommendation service based on the same technology that we use at Amazon.com. And what Personalized provides is essentially an end-to-end pipeline from customers putting in their own data to us figuring out what are the top algorithms that we use inside Amazon.com that we can apply to that data set and then serve the same type of recommendations that we provide. And it doesn't just provide recommendations in the sense of an output of the model, it provides an entire service that could be consumed by mobile and web applications, including cache and real-time recommendation service. So pretty powerful. The next thing was documents. Dealing with documents is very complex, as you all know. Documents are everywhere. They're ubiquitous. You have documents in your tax forms. You have documents in your workforce analysis. You have documents in the emails, communication that you have back and forth. You have documents with inventory management. Everything else that you have to use to manage your organization probably involves documents somewhere. And the way you traditionally look at documents is either using a word model, a character model, phrases model, document model, the tables that you want to extract, the key value pairs in the case of a form. So it gets very complex. Today, we can look at documents analysis in automation, in analogy with the way we look at automating self-driving cars, for example. There are multiple levels of approaching that. But by analogy, you can think about the first level of approaching document analysis like the QR code or highly rule-based document analysis where there's a specific thing that you can extract and you have a rule for that. That's pretty easy. That's simple. The second level is OCR, character recognition. I think everyone here is familiar with OCR. The third level is forms and templates where you know exactly what to look for, where to look for it, and then you can go and extract it. And the fourth level is having enough automation and having your models eventually knowing different types of documents well enough that humans just have to come in and spot check and verify that the machine did the right thing. And the fifth level is zero human intervention, which I think we all believe we're not there yet. So I'm happy to announce that with Amazon TextRack, which I'm going to introduce in a second, we are at the level of human spot checking. And if you want to get into the details of Amazon TextRack, it's essentially what we call OCR++. It's an OCR service to easily extract data from virtually every document. And by virtually every document, I mean every document. So what we do in TextRack is much more than OCR. We get into the shapes and form of document. We look at the photo characteristics of a document. We look at geometric characteristics of a document. A check is like this. A receipt is like that. There are different characteristics of these documents, and we want to make sure we're able to extract all of that. There are forms somewhere, there are empty values in the form, there is a table somewhere, we extract a table in the way a table should be extracted, i.e. we output a table out of the extraction of a table. So, and then also there are documents that have multiple columns in a document, so we want to make sure we can extract those properly so that the output would be multiple columns as well. So it's not simple OCR, it's actually what we call OCR++. And then I'm happy to announce Amazon TextRack, which essentially actually extract documents, extract information out of documents with proper OCR. It could extract key values, it could detect table, it could adjust the confidence and threshold based on understanding the context of the document that it's extracting. So with that, those are machine learning services and solutions that we've built to make sure that customers like you or builders for their own customers can use those technologies that are machine learning and deep learning powered, but don't have to figure out any machine learning. For the custom problems, for the problems where you actually have to build an infrastructure, you have to use TensorFlow, MXNet, PyTorch. Who here is familiar with those machine learning and deep learning applications and products? Okay, a few people. Who works for an organization or in a role where she or he has to interact with data scientists or developers, maybe building projects for them or projects? Okay, quite a number of people. So I think we would all agree that there are a few challenges that are common to everyone that is interacting with building custom machine learning solutions now. One of them is flexibility and cost. The other one is availability to the data and getting the data curated in such a way that it's ready to be processed by the machine learning model eventually. And that's a process that could easily take 6 months. And the third one is the ease of use overall. Machine learning is still, if you think about machine learning in computing terms, all the way up until last year, it was still in some kind of assembly form where developers and data scientists had to get into the details of the math, of the science, and actually building products right the way down to the core. So some of the things that we are doing there, the first thing that we looked at in the whole year of 2018 was to improve the inference cost, training and inference cost. So if you're familiar with TensorFlow, scaling TensorFlow out to multiple GPUs and multiple machines, which is usually required if you have a lot of documents to analyze or if you have a lot of images to analyze, would give you 65% efficiency. What this means is that if you do scale an infrastructure to multiple machines, there is the management of that infrastructure that gets involved. There is data passing across different machines that gets involved. And because all of that gets involved, you lose about 35% of the efficiency that you would have had out of using that entire infrastructure. So I'm happy to announce that we've invested in building teams that are optimizing TensorFlow for the cloud. And right now, we're able to achieve 90% efficiency on 250 GPUs. So we actually went and took the open source TensorFlow, invested in optimizing that for the cloud, and making sure we can optimize that better. And for an example, the ResNet 250 is a very common benchmark algorithm for computer vision, processing thousands of images. The state-of-the-art processing of ResNet used to take 30 minutes. We're able to achieve the same results in about 14 minutes. So that's the first improvement. The second thing is that, like I said, at AWS, we're frameworks agnostic. So we're actually not just investing in TensorFlow. We're investing in MXNet and PyTorch and Chainer and Caffe. If you're not familiar with those, these are basically the programming languages for machine learning and deep learning today. These are the tools that are used by data scientists and developers to build intelligent systems And these tools are abstracting all the math and calculus and differential equation that has to be done in backend in order to build deep learning models. So what we do is that we invest in teams that dig deeper into these tools and optimize those for the cloud and optimize those for inference and training and all these other things. And you could either manage it yourself on the cloud or we could manage it for you. Now, model training gets a lot of attention. Every time you hear someone talking about machine learning, you always hear about training a model. But ideally, what you want to do is to train a model just 10% of the time, because you're not training a model for the sake of training a model. You're training a model for the sake of running a business out of that model. So you want to spend 90% of your time in the inference mode or the prediction mode. And we saw there were some challenges there. One of the first challenges was that, well, one size doesn't fit all. If you have GPUs and you're using GPUs for training a model, that's good and that's appropriate. But if you want to use GPUs for serving a model, well, then GPUs are expensive, and then sometimes you're not really using these GPUs to the full extent of the capacity of the GPU. The other thing is that elasticity is important. During the training phase, you have a lot of data, and then you're training on that data, so that's fine. You know that you have that data set. But during the prediction or serving a model phase, sometimes the data comes sporadically. If you don't have a request to score on, you don't have a reason to use that infrastructure to score on that request. So, and the problem here is that we tend to provide capacity at a high level in order to make sure that we can meet the highest demand. But what if it was possible to bring in some elasticity in that domain? So that's why I'm happy to announce Amazon Elastic Inference. With Amazon Elastic Inference, essentially what we do is that we add GPU acceleration to any Amazon EC2 instance, and with that, we're able to provide about 75% cost savings for our customers. You can think about Amazon Elastic Inference as a GPU chip that gets elastically attached and then scaled to any kind of Amazon EC2 instance whenever it is necessary. And it supports the traditional deep learning frameworks, TensorFlow, MXNet, and it works on Amazon SageMaker or normal Amazon EC2 instances. Now, let's talk about scaling machine learning itself. If you remember last year, like I said, machine learning was still difficult. The process of machine learning will require to choose a machine learning algorithms, and then for that, we provided last year pre-built Jupyter Notebook instances with a lot of examples. It would require optimize your machine learning algorithms, and for that, again, we provided a number of machine learning algorithms on Amazon SageMaker. If you're not familiar with it, it's an end-to-end machine learning platform and service essentially at AWS. And you had to set up and manage your environment for training. And again, for that, we built APIs to make sure that process is done rapidly. The next thing was to train and tune machine learning models. We provided optimization, hyperparameter optimization. And to deploy machine learning models and scale those, we also did provide infrastructure and tools and services for that. So we have a number of happy customers using SageMaker today. Tinder, Intuit using SageMaker for, Intuit is essentially using SageMaker for fraud detection. Formula One is ingesting over 3 terabytes of data per car, per race, and analyzing that in real time on AWS Cloud. So we have a number of happy customers, but it came back to us with a decent number of amount of feedback for things to improve around the platform for their experience. But the first thing that I think we'll all agree on is that it all starts with data. So we still need to find a way to get the accurate and appropriate data set that we need to train our machine learning models available for machine learning to be able to leverage that. And so we started thinking, how can we make it easy to essentially obtain high-quality labeled data for the process of supervised learning? And if you think about computer vision, if you think about analyzing a video, video comes into multiple frames. And to label these frames of video in order to do computer vision on that, you have to use a human workforce essentially to go through every single frame of that video and then label every single object on every single frame of that video for you to be able to build a model off of that. And so I'm happy to announce that we launched last week Amazon SageMaker Ground Truth, which is a managed service for building highly accurate training data sets and reduce the labeling cost by up to 70%. Now, if you're familiar with Amazon Mechanical Turk, which is about 500,000 people out there in the world that can help you label your data set, images or text, SageMaker Ground Truth works a little bit the same, but we've done more in Ground Truth. One of them is you can now have private workers. If you have a private data set that you want to label by your staff, by your employees, or by people that have a specific skill sets like medical doctors or legal folks that can understand the context of a text you want them to label, you can do that. Or you could also work with third-party vendors on the platform like iMerit, and what they would do is that they would provide SLAs and provide appropriate annotators. But the other interesting thing, and the thing that I'm happier about on the platform, is that you can do quick labeling using a managed machine learning model that we do provide on the platform. That makes it easier for the models on SageMaker Ground Truth to learn from the human annotators and continue the process of annotating automatically, which makes it easier for you to accelerate the process in general of annotating the data set and eventually saving up to 70%. Now, as far as driving the ease of use is concerned, we've also provided a number of algorithms on the AWS Marketplace, machine learning algorithms. The rationale here was, how can we connect people that have the skill set as far as building machine learning algorithms are concerned and people that have the needs of using these machine learning algorithms? So on the marketplace, we can now connect sellers, which basically bring their own machine learning algorithms and keep their intellectual properties, and buyers who can purchase these machine learning algorithms and apply them to their custom data set. So very powerful connection on the marketplace. And so I'm happy to announce that we have over 150 models and algorithms available on the AWS Marketplace now, from natural language processing to image analysis, you name it. Now, switching gears, the next thing that I wanted to talk about rapidly is doing machine learning everywhere. It's good to build machine learning models, but ideally, we want to run machine learning models on vehicles, on security cameras, everywhere in the real world, as opposed to just doing that on the infrastructure. And some challenges come in the picture. One of them is, well, on the cloud, you're only constrained by time. So you only have to throw infrastructure at your processes in order to get the processing going faster. But when you bring machine learning to the real world, like cars and then your microwave oven, your fridge, you're constrained by a lot of things. One of them is the space you can have, the memory, the amount of CPU, the battery life, and all of these things become challenging. Now, to make things even worse, all of these artifacts in the real world usually have chips that are built by different manufacturers, Intel, NVIDIA, Xilinx, you name it. And on the other side, you have all these deep learning and machine learning models that are built with different, softwares, MXNet, TensorFlow. What if it was possible to put something in between that would essentially understand how these deep learning models are built and then convert that into binaries that can essentially run on every hardware out there? And that's why we built SageMaker Neo. SageMaker Neo is essentially a deep learning model compiler that lets customers train models once and then run them everywhere with up to 2x performance in speed and then no loss in accuracy. So SageMaker Neo is very simple. With SageMaker Neo, our customers can build their machine learning models with MXNet, TensorFlow, or whatever they want, compile those models with SageMaker Neo, and be able to run them in every type of infrastructure that they want to work with. Now, what's next for machine learning? If you think about the world of supervised and unsupervised learning that you probably heard about a lot, supervised learning will require you to provide a lot of labeling data. You can solve complex problems with that, like computer vision and then natural language processing. With unsupervised learning, you probably just want to classify some of your data set, and you don't have a lot of concern as to being very exact or as to having a lot of data. The area where you want to collect a lot of data to get to solve not complex problems is probably somewhere you don't want to go. But the area where you don't have enough data and you have complex problem is an active area of research where reinforcement learning can be very helpful. If you're not familiar with reinforcement learning, at a very high level, it could operate within a simulator without needing a lot of data. You can train essentially an agent or reinforcement learning algorithm that learns from interacting or from experience within that framework or simulator. And once it's learned there, you can take the learning and put that out in a real agent, like a self-driving car or anything like that. So reinforcement learning is giving a lot of promises in robotics, in autonomous vehicles, in resource allocation, inventory management, and everything else in between. Now, what we're doing with reinforcement learning, I'm happy to announce that we have released Amazon SageMaker RL, which essentially provides reinforcement learning capabilities to the cloud. With SageMaker RL, we provide simulators and the integration with deep learning frameworks, and it's fully managed and makes it possible for our customers to build reinforcement learning agents, train and optimize those within simulators that we provide, like Amazon RoboMaker, and eventually, after they're happy with their agents there, they can deploy them in the real world. And to see reinforcement learning in action, we've created this little puppy. This car is called the AWS Deep Racer. Deep Racer is essentially a self-driving car that we built to make sure that your developers in your team can experience reinforcement learning with our simulators on the cloud and deploy that in a real car in Deep Racer and use that for operations in real life. Now, accelerating a little bit here, the next thing that we created next to Deep Racer is a Deep Racer League to make sure that developers can compete as they learn reinforcement learning. And we actually created a league because internally at Amazon, we realized when we were building Deep Racer that teams started competing. So we said, well, we're just going to create a league and get everyone to compete. Now, the other ways to get started are the Machine Learning University. Inside Amazon, we have created a machine learning university that we use to train our own staff with machine learning. So I'm happy to announce that we've externalized the machine learning university's content to everyone, and it's free. So send your staff there, get them to go ramp up on machine learning on the MLU. And the last thing is the Amazon Machine Learning Solutions Lab. So everything I called out earlier is a technology piece of it, but there's also a people and professional services aspect of what we provide. With the Amazon Machine Learning Solutions Lab, it's possible to brainstorm and have custom machine learning model trained and built with the help of our staff. And I'll be happy to talk to you if you have any interest in that. With that, thank you so much for your time, and thanks for having me. I'll be out there for questions.